All right, good morning, everyone. We're all ready to get this thing started. Did you all get your coffee, get your energy back from being mixy last night, right? How was your evening last night? No, nothing? It was all right? All right, I can tell you mine was not interesting at all. I went to the gym and went to sleep because I need to make sure that I can give you all a good show this morning. Before I get started, I need to throw out a message from our legal team. I'm not going to read it to you. All it's saying is that you can't trade on any of the information that I'm sharing today, but there's nothing in here to trade on, right? All right, let's talk about it, right? So how many software developers do we have in the room? Software engineers, front end, back, most of us, right? So I'm sure if I were to ask all of you, what would you want to be doing for most of your time, right? I'm pretty positive that you'd say you want to be building cool projects, right? You want to build awesome things. You'd want to do that pretty much 100% of your time. You'd rather be in your IDE rather than dealing with issues. But truth of the matter is that we have this narrative that as software developers, we have this want to build cool things. Sometimes it's not always true. We have bugs and issues that need to be fixed. And there's a growing narrative of once it's shipped out into production, we don't care anymore. It's ops problem. And I could say that that felt true for a while until this happened, right? You build it, you own it. The market shift, the way that we build software changes, the software itself changes, it's more complicated. We're not doing monoliths anymore. We're all working in these distributed environments. So now not only do you build it, you run it, you have to monitor it, you need to keep it secure. Our concerns are growing, our expectations are growing as software engineers, all right? So with those expectations getting higher, we're responsible for shipping things faster, right? We're building more modern applications. They're more distributed. Sometimes it's hard to even know what's going on where things are deployed to. We're expected to drive more business outcomes and do that with less errors. So as an engineer, the truth of the matter is that we're not going to spend most of our time just building really cool things. We're going to be dealing with bugs and issues throughout most of the software development lifecycle. And in this process, the regular occurrence is that we're acting reactively, right? Something has to break, we try to figure it out, we go and fix it. There's a lot of noise, we're dealing with alerts, we're being woken up in the middle of the night, we have to figure out what's happening, and we just don't have enough context sometimes, right? So that's where this idea of shifting your software development processes left come into play. It's trying to solve all these issues, allowing you to act more proactively to what's going on with regards to the performance of your application, giving you the insight that you need to make decisions without having so much noise, being able to act quickly and just create better software. All right, so I said a lot of things. I'm going to pause. Let's clear up some of the buzzwords. So what is shift left software development, right? What is it? Why should I care? And how do we do it? Right? So shifting left is an approach where you emphasize early in the process concerns that we'd be thinking about once we've gone through testing and deployment. We're starting to move some of those concerns earlier into our software development lifecycle into, let's say, the planning and the design phase, right? So in a typical software development lifecycle, there are several stages where you're going from gathering requirements, you're doing your designing, your development, your testing, you deploy, and then you maintain and analyze, and it kind of iterates. It's a cycle. We're never really done. We're always trying to create better software. Right, and so for this talk, I'm mainly going to focus on what it looks like to shift some of those concerns earlier in the process. I'm going to focus on observability and software security as two of the main things that you want to be thinking about as you're shifting left. This is what a software development lifecycle tends to look like, right? So I'm going to group them into a few stages. There's going to be the plan and design, build and develop, the test, deploy and release, and then a monitor and analyze phase. In a traditional model, we're normally thinking about some of the things that are happening with regards to the performance of our software, the security of our software, once we've gone through testing and we've deployed out into production. People are using it, they're experiencing issues, things are crashing, and now we're trying to figure out what's happening so we can go back and fix it. But because we didn't really think about some of it early enough, we don't have access to the right data. Thank you. You might be in a situation where you don't have access to the right data. You're already dealing with errors because things are live and out in production. You have customers that are facing challenges. You're providing a poor business experience. And at this point, you're not really thinking about quality. You're just thinking about keeping things up. The shift left model takes a lot of those same concerns, move them much earlier into the process, starting really at the design and plan phase to where you're really paying attention to the quality of the work that you're doing. You're making sure that you're providing yourself with enough data to be able to make decisions later in the process. But one of the biggest benefits of this is that you have a lot less errors. Things aren't deployed yet. You're not dealing with users actually trying to use the application. And we all know that users don't tend to take the happy path at times, right? So this gives you more room to actually think through things and put some things in place, right? So this is what that looks like. Taking things out of that monitor and analyze phase, even some of the deployment process, just shifting them way earlier into the beginning, right? All right, so another buzzword that I said was observability, and I want to clear that up just so everyone knows what I'm speaking about. I think we're all familiar with security at this point, right? I'm sure if we're all engineers in this room, at some point we got a message from our team with a security ticket, and you have to stop your work and go and fix it, or you get screamed at. But observability is a concept that's been growing over the last few years, and it's not as known to some the engineering personas. I'd say DevOps and SREs definitely know what observability and observability tooling is, so I'll clear it up now. Observability is the process of knowing what's happening within the applications that you're building and deploying into production. So it's thinking about what's happening, why is it happening, but also how is it impacting your users, right? My app is performing slowly, what's causing it to perform slowly, and what's that user experience like? What's the impact on my business outcomes? And then taking the data that's being reported from your applications and services and using those as a method to be able to answer some of these questions. And then using that data to also drive decisions. Should I be continuing the velocity in my roadmap versus should we be slowing down and doing some reliability work to make things a bit better? Right, so if we were to think about it, we all have cars, we all drive. I'm sure we've been in a car. So observability in the concept of a car would be your dashboard, right? If you're driving your car, your dashboard's gonna tell you pretty much everything that's going on with the car without you needing to stop and get under the hood and try to figure things out. It'll let you know your speed, right? I'm doing 100 on I-95 because I'm from Miami, and that's how we drive. Or if that check engine light comes on, it lets you know that you may wanna slow down, you may wanna stop, try to figure out what's happening. Even though your car's still running, there's an issue that you need to pay attention to. That's what observability is, and that's how you make decisions from it. All right, so let's get into what a roadmap looks like, and I'm gonna apologize in advance. There's a lot of text on these slides, right? I thought the information was so important that I didn't want to leave anything out. So let's get your cameras out, take some photos. I won't be reading from them verbatim, but I did throw a lot of words on there, which I try to avoid. So best practices for shift-left software development. This is what a roadmap looks like. If we're thinking about the plan and design phase, right? This is where you're starting your planning as early as possible, moving a lot of that planning, a lot of that thoughtfulness into the plan and design phase, right? So in the planning phase, you want to get your stakeholders involved. It's going to include your end users, your business analysts, subject matter experts, your executives. Get them all at the table so we can gather comprehensive requirements, right? Focus on understanding the desired outcomes, use cases, look for potential edge cases, like try to figure out some of those unhappy paths on the way that someone may actually be using your software or your services. And you collaborate cross-functionally to make some decisions around the applications and the services that you're going to build, right? And you want to do design reviews throughout this process to try to find potential risk and bottlenecks. So that's just what the planning phase looks like normally. Then with observability and security thrown into that context, in observability capacity, you want to be thinking about the requirements for your observability strategy. What data do you need access to? Whether it's logging, what metrics do you need? You want to figure out what type of tools are you going to instrument and put into place. And you want to be thinking about what your key performance indicators are going to look like, starting to surface some of those KPIs. So in order to make sure that I'm providing the right quality of service to my users, what information do I need from my system for me to be able to monitor it? Let me put in a little bit of context for you, right? If I'm a front-end developer and I'm working on a checkout service, I want to make sure that when a user's entering their credit cards and they hit that submit button, that I have a positive response in under 500 milliseconds. I need it to be fast. Give me the money, right? If it's too slow, I don't make enough money. So anything under that 500 milliseconds is a poor experience. The service might still be working, but we need to make some improvements there. So that's the quality of service. That's going to be the KPI that I put in place. And now I need to make sure that I instrument my applications, or I'm thinking about the data that I need to make sure I could check that metric. And I may even want to be thinking about it in a custom way, right? So some systems you can instrument and it's like magic. They give you all of your information out the gate, but they're not going to give me something like my shopping cart total, right? And so I need to be thinking about that. So if my cart was to go down, I want to know how much money I lost or what's the average I'm losing when a customer leaves that cell. So this is some of the thought process that you're putting in place in this design and planning phase. And then for security, you're thinking about your security requirements, right? What are the industry standards, your compliance regulations? You want to be thinking about your best practices and thinking about the tools that you want to put into place. The control that you need for your systems and your data, you're conducting security threat models, and you're thinking about like your access control policies, the encryption protocols that you're going to put in place, and your overall system architecture, right? You're giving a lot of thought into how can I make a safe and a secure system before you ever open your IDE and write your first line of code. Once you've gone through that process, then you're ready to shift into your develop and build phase, right? Now I have my IDE open. I'm living in a space that I really want to be in most of the time. I'm actually starting to build and implement. This phase looks like writing your code, following your best practices possible, following code standards, thinking about maintainability and readability of your code, documentation, right? Conducting code reviews to catch any issues, security vulnerabilities, or performance issues early on, and then utilizing any automated code analysis tools that are available to you to make sure that you're enforcing quality standards. Things like, I'm sure we all use linting tools, right, to make sure that we're following kind of like our best practices or our company practices in the way that we write our code. And from an observability and a security standpoint, in this phase, you're going to be doing your implementation. So implementing your frameworks and libraries that's going to give you access to that data, thinking about what services or what type of instrumentation that you want to do. So if you look on the screen, there's a New Relic logo. I'm from New Relic. There's OpenTelemetry, there's Prometheus. There's a ton of ways that you can collect the data that your application is going to be using, and this is where you're starting to implement a lot of those libraries and your frameworks. For a distributed environment, you want to be thinking about distributed tracing, making sure that I have that mapped out, so as my services are communicating to each other, I can follow them along every step in this process and look for any bottlenecks or slowdowns, right, and then go and solve those, or at least understand which team I may want to reach out to if it's not a service that I own. From security, you're applying your best security practices and guidelines at this phase. You're making sure that you're implementing secure communication protocols. You're doing your input validation. You're encoding your outputs, right? You don't want a security ticket to pop up saying, hey, a user can just change that user ID and get someone else's information, right? So we're thinking about how can we sanitize as much of our application as possible, building that in, and then we're utilizing security libraries and frameworks to prevent common security issues. So that's the work that we're doing in the develop and build phase. We're actually implementing a lot of the strategy that we developed in that design and plan phase. Once we've done that, we go into testing, right? How many people love test? We had a lot of developers in the room. I don't see a lot of hands up for testing, right? I think it's true to say that we have to do testing. It's mandatory. It's not necessarily a thing that we all love, right? But in the testing phase, we want to start testing all activities on all the things as early as possible. And so this phase normally looks like starting with your testing activities, utilizing unit tests, integration tests, functional testing. You're going to leverage automated testing frameworks. I'd say the more that you can rely on automated testing, that's going to be best, right? Because it's going to allow you to eventually create this system of continuous testing. Everything that you're writing, you're testing before it goes out into production. You're making sure that you were thoughtful about the code that you created. And then you're also implementing security and performance tests in this stage as well. So you're not just testing for a specific result from a method that you may have wrote, but you're also making sure that you have the right data from your observability instrumentation and that you're getting the right security data as well. From an observability and security standpoint, with observability, you want to make sure that you're testing that you're getting the right data in, that you have access to the right data, and you know which teams you may want to be communicating with. You're validating things like your log outputs, your monitoring system, you're doing test runs, and you're just making sure that you're being thoughtful so you can have a solid and secure observability framework available to you. In security, you're doing security tests, you're doing vulnerability assessment, you're doing penetration tests, you're identifying any potential weakness within your application. You're testing for common vulnerabilities within packages, and I'd say you definitely want to be checking your open source packages, right? More than 50% of all open source packages that we're leveraging within applications that we're building have at least one severe security exploit that exists within the application. And so by adding that to your project, you're now adding that vulnerability within your project. So you just want to make sure that you're thinking about what you're actually using or what you've implemented in that build phase. Once we've gone through testing, everything looks good. We caught as much of it as possible. We've done our fuzz testing for security if you're using something like IaaS. we're ready to go into that next stage, and that's gonna be our deploy and release stage. And this right here, I'd say the biggest takeaway is just automation, right? You wanna reduce as much manual work in this deployment stage as possible, right? So this stage really looks like automating your deployment process as much as possible so you can build consistent and reliable releases. For most of us, that means implementing CI/CD, right? So continuous integration, continuous deployment. That's gonna allow us to have more frequent and more incremental deployments, being able to go from something like when I was at a startup, we were deploying maybe once a month into once a week, and then a few times a day. And then at New Relic, we're deploying hundreds of times a day on a regular basis, right? So if there was a break or a change, we just have an incremental rollback that we have to think about instead of this massive deployment that we did. From observability and security, you want to automate your deployment process and instrument your observability components into this process as well. So adding your observability components into your deployment pipeline, using tools like Terraform or Pulumi, that's gonna allow you to build out dashboards, do instrumentation, apply observability as code, and work within the scale, right? So it's gonna reduce any of that manual work and toil, and it's gonna allow you to have a structured process in place. So I know for a fact, anytime we deploy or roll out a new service, I'm gonna have at least these set dashboards or this set amount of instrumentation out of the gate because it's a part of my deployment process. And for security, you're doing the same thing, right? You're including your security configuration for your servers, your databases, your network infrastructure, you're encrypting any of your sensitive data, and you're employing any as secure of your transportation protocols as possible, right? So we're hardening as much of it, we're implementing as much of it in the deployment process so I don't have to be thinking about it and doing that work manually, because one day I may do a great job, that may come to render, go out, have a great time getting really late and do a terrible job the next day, right? But if it's automated, that's not really gonna happen. Once this is all done, we go into the monitor and analyze phase. We've gone through everything, we've tested, we've deployed into staging, we made sure that everything was good to go there. Now we're in production, and we wanna make sure that we're providing the best experience to our customers, our end users as possible. So in this phase, we're actually getting an understanding of what the standard set of performance or usage looks like for the application. Like, what is our baseline? So we've established a robust monitoring and logging mechanism to make proactive decisions or to have access to the right data to be able to make those decisions. Created a feedback loop for the development teams and the end users and leaders within our organization. And we're prioritizing bug fixes and security patches to make sure that we're providing our users with the best experience possible. We're continuously monitoring our system, and then we're using that data to say, okay, like I said, with the check engine light, it popped up. Now I need to slow down. I'm gonna go and see what the issue is. I've got alerted. I'm gonna fix this service, make sure I can get it out into production. From a security standpoint, you need to really be regularly updating your components and your libraries and your frameworks. Like I said, anything that you're using, let's say a third-party package or an open source package, does expose your applications to vulnerabilities that will pop up over time. So you're gonna make sure that things are regularly updated and that you're providing users with the most secure code as possible. And then what happens here is this isn't the end of the road, right? Oh. Although we come to the, can I get a sing along, to the end of the road? No, and no. All right, truly it's not the end of the road though, right? It's more of like the song that never ends. Remember that one? This is the song that, no? Okay, whatever. Because you start over and you're going through this process over and over. Every time you build a new service or need to make an update, you go right back to the beginning and you're just thinking about it as much as possible. Right, so what I could say is a new software engineer or a software engineer that's just getting started with shifting left their development process, things that you want to be thinking about is fostering as much collaboration as possible, automating as much of your process as possible, thinking about things in a DevSecOps model, right? So we all probably heard of DevOps where the dev team and the ops team have some weird mix of a relationship, but also adding security into that and then continuously learning, right? Being up to date with emerging technologies, industry trends, and best practices is gonna be key for having a successful shift left process. And then just think of it as shift left is a mental shift before you ever open your IDE. It's changing the way you think about the way that you build and develop your code. And so with that said, there I am. I am Jemiah Sius, the Senior Director at New Relic. It says product management, that is developer relations, dev experience, lots of things. I'm a Miami native. Let's go Heat. We're taking it home, right? No questions about that. 15 years in coding. I started off as a designer, taught myself how to code, and just been moving forward. Very passionate about building and working within communities, lifelong learner. I am not interested on social media at all. But if you want to connect, there's my LinkedIn and there's my Twitter. And thank you all so much for your time. Hope you enjoy the conference.